Equations of motion question. The question says, a car is traveling along a road at 30 meters per second. 30 meters per second here is the initial velocity u. When a pedestrian steps into the road 55 meters ahead. So we have the car here and a pedestrian passing. Between the car and the person there is 55 meters. The driver of the car applies the brakes after a reaction time of 0.5 seconds. So he applies the brakes after 0.5 seconds from seeing the person. Let's say the red point here is the time when he applied the brakes, and the car slows down at a rate of 10 meters per second square. So A is 10 meters per second square. The question here is what happens? So let's first get the distance that the thinking time the driver of the car took before it stopped. We have the initial velocity u 30 meters per second. T is 0.5 seconds. So we need to get d, d1, u equals d over t. So the total distance equals u times t equal to 30 meters per second times 0.5 seconds, which is equal to 15 meters. So the distance d1 that the driver had traveled before stopping is 15 meters. Now let's put the given. We have s unknown, u equals 30 meters per second, v equals 0 meters per second, a is 10 meters per second square, minus 10 meters per second square, and t is unknown. So let's use this equation, b squared equals u squared plus 2as. We substitute the numbers, we get 0 equals 30 squared plus 2 times minus 10 times s. 0 equals 900 minus 20s. So s is equal to 45 meters. So let's see what will happen now. The total distance between the car and the person is 55, and we got that the thinking time before he stopped was 15 meters, and the time until he totally stops is 45 meters. We get that the total distance when the car stopped is 60 meters. And the distance between him and the person is 55 meters. So what will happen here is that he won't be able to stop before hitting the person.